They see me rolling, they see me hating, driving a car that depreciates, perhaps. Well, maybe why does that happen? Why do cars start out at a certain amount of money? Let's say a car could start out at 50K, and then as soon as you leave the lot, why did it go down to 45K? What's this change? What makes this thing happen? Cars don't normally look like this, but let's imagine for a second, you have this car and you paid $50,000 for it and it still looks brand new, but why is it now 45,000? Some things that may attribute to that, I'm sure you can think of these on your own. Age, the mileage, condition. If you have a fender bender and never get it fixed, it's probably going to keep that price from going up. It's going to only really bring it down, honestly. Options, you might have several ways you can buy a car. We mentioned Carvana might be a way. You might have someone who works at a dealership, someone who's a family friend and trying to get rid of their car. There are a few reasons why reselling a car sometimes isn't what we expect it to be. And these are some more conditions why. Perhaps location, perhaps popularity or demand. Nobody really wants the car, it's going to go down in value. Or if the company goes bankrupt, maybe sometimes that bumps it up. But we're just talking about depreciation today for cars, so values that go down. What does that look like as a percentage? Let's talk about it. Let's imagine that we buy a car for $10,000. So we buy this for $10,000. And we see that this is going to keep depreciating as follows to the point where it's honestly not worth all that much. So let's imagine in year one, it's $10,000. In year two, the car is worth $85,000. Sorry, $10,000 to $8,500. We could see that this is depreciating every year 15%. So every year that we own this car, it's losing 15% of its value and it's only retaining 85% there. So we call this exponential depreciation, which is just one way that these can depreciate, cars in particular. We can actually make equations that show how this works if we keep noticing that we have a jump from 10,000 to 8,500, and we know that there's 85% remaining. We can make this type of equation because after so many years, we'd want to know a pattern is happening. That's what we're aiming for, where we're starting with 10,000, but we keep multiplying that value by 0.85 or the 85% that's remaining. Eventually, we can say that we have this type of equation, which you might have seen before, where A could be our starting value, so our start. B, we consider the rate, but really this is taking 100%. So again, it's taking 100%. Terrible 100. It's taking 100% and then deducting R, which in this case was the 15% of depreciation. So that's how that one could work. We see that it's not always linear. Sometimes this goes down. And so with this example, it makes sense that if we were working with an equation, this 10,000 is our starting value because that's how much we bought the car for. Inside parentheses, what this 10,000 keeps multiplying by, we know is 0.85, or we can think of it as 1 minus 0.15. So there we go. That's a good introductory to this exponential depreciation. Another way that cars can depreciate over time is with a linear depreciation. We see here we have this straight line depreciation. It's even written out. How nice of them to do that for us. This equation here, y equals negative 2,680x plus 26,800. We would be asked how much the car is worth after 48 months. Key thing to note here is that X is going to represent the number of years in this process. So A is pretty simple because you have your equation And you could pretty much just plug in where x is 4. And that's pretty simple follow through on your part. Just plug in where it's 4, let the calculator do the rest of it. That one is not too bad. How about for 75 months? Well, I know that this is 6 years and 3 months. So how do you think we could put that in? How do you think we could go about making that happen? Well, you could put it in as 6 and then 1/4 of a year. So instead of x, put in 6.25, call it a day. That's that one. So A's done, B's done. What do you think about M? M represents the length of time in months when the car still has value. Can you do that algebraically? Try it. Well, we know that we've been taking the months and dividing it by 12 to get the number of years. We could do just that. I don't think this one's too tricky. If you just wrote this, I think that's pretty good. If you took it further and wrote out all this, taking the negative 2,680, dividing it by 12, getting you this fraction, you could do that too. Nothing wrong with that. Take a moment and read through this problem, and we'll touch base on it shortly. Winnie purchased a new car for $54,000. She's determined that the straight line depreciation will go all the way to 0 over 10 years. When she purchased the car, she made an $8,000 down payment, financed the rest with a 4-year loan at 4.875%. We can use the monthly payment formula from the last chapter to determine the monthly payment to the nearest cent. We're creating an expense and depreciation function, graphing them, and interpreting how everything's going to change up. Well, first, let's think, how much is this loan going to be? I know that the car was this much, but we put down this much. So how much is this 4-year loan going to be? Pretty simple to just take the car payment or the car amount, deduct 8,000. So our loan is going to be $46,000 for 4 years at 0.04875 for that. So I'm going to swing on over to our equation shortly for monthly payment, and we'll see how we can take it from here. Remember this old thing? Just like I said, we have our loan amount, we have our percentage, but put it in as a decimal. If you carry through all of this and let the calculator do that work for you, you're eventually saying that every month you're paying approximately $1,056.75 or 74-ish cents. So as far as the expenses go, and I shouldn't have said deduct. Well, in a way deduct, but the expenses eventually just keep adding on, you know? So this does bring in interest. So interestingly enough, if we think this part out, and this is over the span of 4 years, so we have quite a bit going on with this. We definitely pay some interest on this, but our expenses would be this equation here. Because again, we gave 8,000 already, and we keep giving this amount every month. So this is actually going to end the video. This just covered the expenses. I think that's all for this one. Yeah, we don't go too deep into these types of problems. So sorry if I threw you off with B and C. Hope that this video was helpful. If you have any questions, let me know. Thanks for watching.